Hey everybody, it's Eugene Lisho here, and welcome to Click 3D. This is the program where we talk about photogrammetry, laser scanning, and all kinds of things 3D related. Today I'm going to be talking about targets, and it's a topic that I haven't really seen a lot of discussion on. Sometimes it comes up on forums and things like that. So I thought I would do just kind of a quick summary of a number of different types of targets and where they're applied. And so I'm going to kind of start at the beginning and just really ask the question, why bother with targets? Why even bother? You got to carry them around. You got to put them up. Sometimes they're big and bulky and they take up a lot of space. You got to leave them. Sometimes you got to protect them. There's all kinds of reasons why you wouldn't want to use targets. And a lot of people, I think, try to avoid them when they can. But there's just some scenarios where you just can't get around using them and you have to use them. So depending on what you're using, if it's photogrammetry, if it's laser scanning or whatever, you really need to decide on what kind of target to use. So first off, why even bother? What's the purpose of a target? Well, I'm going to show you a few images here that I think are pretty interesting. And I actually just shot these while I was on vacation here. So this one here is a kind of monument that was at sort of overlooking like a cliff, and this was overseas in Portugal, and you can see there's a number on it, and there's a little crosshair up here with a little dot in the middle. So this is something that a surveyor would use to locate. And so you may use this for monitoring. You can come back and check it, and then later on you can see if something is moved or that part of the earth is moved. Or maybe you want to compare this position with something else and see if, overall a whole number of these things are moving. This is another one here. This is one that I found in a similar location, and you can see, it's got some kind of a number here or whatever, and then there's like a center point that you can measure from. And then another one here, just walking, and you can see on the ground there's a triangle. Somebody's put a little nail into the concrete, and basically the center of the head of the nail is a type of target. So this is important because obviously people find it really important to go back to. They want to be able to go back to the same spot and be able to locate that point. Now, I have to say, sometimes even myself, when I'm traveling or whatever, I don't carry these kinds of things, or I don't do these types of things when I'm working with photogrammetry or with laser scanning, but using the same principle of being able to mark something and have it consistently show up in multiple scans or in multiple photographs is not uncommon. It's something that a lot of people do. And even when I don't have a target available, sometimes I've just got tape. And so this is an example here where I've just marked some duct tape, some black duct tape. I made an L, and usually what I do is I use the inside corner, and that's kind of like just a discrete point that I can pick off, whether it's in the scan or if I just need a quick reference to kind of go back and check to. Sometimes I'll just go and I'll measure 2 points, and I'll just make these 2 little L's, and I know that I want the measurement between those 2 points, and I can always go back to them. This is another example. This was a scanning project that I had done, and you can see here, again, I'm just carrying duct tape. So I put down some white duct tape, and then I put down some black duct tape, and that serves as a type of checkered target. So you can make up these targets very easily. You don't have to print them out, or they don't have to be big and bulky or whatever. You can kind of make them up on the fly, but of course it's always better to have a nice, highly accurate manufactured target if you can. So what's the point? What's the point of a target? Well, if you think about it, when you're looking through a telescope and you've got a target, you want to find a specific point. So in our case, when we're dealing with 3D technologies or photogrammetry, whatever it is, right, you want to be able to pick a very, very specific point. And the problem is, let me give you a very simple example of way back when people were doing things like total station surveys. You'd say, I want to know the distance between one pole on one side of a road and maybe another pole. And it's like, okay, no problem. So somebody goes and measures it, and they've got 2 points. But the problem is, you don't know where they took the measurements from. Was it the inside of the pole? Was it kind of on the side? Did they, measure the diameter and then choose the center? So being able to locate a very, very discrete point means you know where the measurement is taken from, but it also means that you can go back in the future and locate it again in the case where you have a permanent marker or whatever it is. You know, sometimes there's a plate or a physical thing, a screw or something that's not really going to move that you can go back to. So having a very specific coordinate, an XYZ coordinate, is something that you can always go back to. And that's why the checkered target is very, very popular. And it works just like what I showed you before, like a crosshair. It is a type of crosshair if you want to think of it that way. But of course, you have two black checkers, two white or bright colored checkers, and where the two, the middle, where the two corners of the squares intersect, that is the area that you want. It's the center of the checkered target. Now, checkered targets in the case of, for example, a laser scanner have often what are called normals. Okay, so normals are important because they will give you a direction. So if I just picked a point and I said, well, here's a discrete XYZ point, I don't know which way it's pointing, or I don't know which way I was when it was facing me. So for example, if I had this checkered target that's on screen and I didn't have this arrow pointing out, I don't know if I'm picking it from the back side or from the front side, and sometimes that is important. When using checkered targets for laser scanning, okay, you often, they're often the best when they're perpendicular, okay, so when you get to a very, very shallow angle, okay, or a very oblique angle to the targets, they don't work out all that well. So checkered targets are very useful when you're moving towards or away from them. So if you have a long hallway and you have a checkered target down in front of you, if you're moving towards it and you keep scanning and scanning or photographing or whatever and you're moving towards it, that's really, really useful and very, very helpful. Now, this idea of position or normals is obviously a limitation. So if you're on a wall and you have a scanner and you're moving around, then you have a problem because eventually you're going to be at a very oblique angle. So they have some limited use when you make them out of paper and you stick them on a wall or whatever. But there are other types of targets that are checkered targets that allow you to swivel. And so this particular set of targets here that I'm showing has a swivel down on the bottom here and then along the sides. So you can move this both vertically and horizontally, okay, so you can rotate it in different ways, but the center point always stays in the same spot. So what this is useful for is if you mount this on a tripod or something like that, and the scanner is moving around and it starts to get oblique, you can just rotate the target to face the device, okay, whether it's a total station or whether it's a scanner or something like that. So these can be really, really, really useful. And they're used all over the place. You find them. And in fact, these are some photos that I took just a few weeks ago. And watch this little video here, and I'll show you. You find them everywhere. So I happen to be at the airport, and I know I'm doing a video on targets that's coming up, and sure enough, right down there, what do we got? Yep, checkered target. So obviously somebody's been doing some laser scanning work here. All right, so there you go. You can find these things everywhere. I've used them myself in many cases. They're a great way to just, piece of paper, you stick it up on a wall or something like that. So checkered targets are very, very useful. Now, the other thing about many of these types of targets is that their size is not all that important. So you can have a very, very large target. Okay, I've got some larger ones that are behind me here. Or you can make them very, very small. So in the case of bloodstain pattern analysis, often we'll use very small targets, just little circular dots where you laser print the corners of the square. So you can see the outside of the square gets cut off on these particular targets, but when you place them on the image, you scan them or you photograph them, you can find very quickly where the centers of these little targets are. And this is useful in matching a photograph to a laser scan when you're doing a bloodstain pattern analysis. Now here's another type of target that I just saw recently on LinkedIn. And this is my good friend here, Barry Bassinet. He's been a previous guest on Click3D, and talking about imagery and all kinds of stuff. But this is something that he posted, and I thought it was a really cool target. And part of the reason is if you look at it, you can kind of get closer and closer to the center here, and you get a smaller target inside of another target inside of another target. So it makes it a lot easier to sort of narrow down where the center point is. And I actually did a very brief interview with Barry, and I'm going to play that now so you'll hear it from his own words. Hey Barry, thanks for being here today.
Well, nice to be here with you again, Eugene.
Yes, back again. You're becoming a regular. Well, today's topic is going to be targets. And so I wanted to ask you about something that I saw you post recently, and I'm going to bring it up here. It was this one here that I saw on LinkedIn, and I thought, wow, that's a really cool design. And of course, I'm talking about, you know, checkered targets, spherical targets, and different types of photogrammetry targets, coded type targets, and that sort of thing. But this one is a pretty interesting design. And so I was wondering, you know, you have a lot of experience with photogrammetry, and over the years, maybe tell us about some of the different types of targets you used, and then what prompted you to come up with this particular design.
Okay, well, there are, as you say, there are lots of different targets out there. I think, especially the new auto recognition coded targets. My background though is working in more close range photogrammetry, where we've been using photogrammetry in industrial measurement. So things like car bodies, aircraft, profiles, shapes of things. It's really essential there that we get to measure the control points very accurately. So we'll be using optical instruments, total stations, to shoot the targets. Appreciate, you know, if you're doing aerial stuff and GPS, then, you know, obviously you've got different, but we're having to get targets centering down to sub 0.1 of a millimeter. So the problem with that is, well, a number of things. First off, if you're trying to shoot a black and white target with a black line, it's very difficult to see. And the other thing is, I've borrowed this from my background in industrial metrology and optical tooling. And what people there use is they use paired target lines rather than a scale rule to line up, because the human eye can easily see, or more easily discern, offsets and symmetry. So it can see, for example, that you're slightly out of center of a paired line. You may not be able to measure it, but you can certainly see that it's out. It's a weird thing about our brain and optics and things. So this was designed really based on, sometimes I can be very, very close to the target and sometimes far away. But this gives me a consistency of measurements and a consistency of what we call bisecting the signal and bisecting the target. So that's really what it is. You use the different paired lines further away. So if I'm less than about 5 meters away, I'm going down to, in US money, the paired lines at the bottom middle are only about 0.02 of an inch separation, and going out further and further. I just find that this gives me a consistent measurement, and also then if I need to pick that control point in my photogrammetry software, it gives me more than a fighting chance. The critical thing in photogrammetry is the accuracy of your control. I mean, there's lots of things out there that will help you stitch, but you've still got to get scale and you've got to get control in. I just find these targets useful. Right. The original design of these is in black and white. I changed it to this sky blue and primrose yellow. And the reason for that is just an article I read about color. And the visibility and why emergency vehicles are painted different colors. In England, we have red fire engines. Apparently, that's one of the worst colors you can have because it just disappears in the dark. But blue and yellow is one of the common things that's used on emergency vehicles all across the world. And the reason being is because it's the best combination visible in different light. So I've got used to using these because sometimes you put photogrammetric targets in an area that originally was lit, but then during the shoot becomes dark.
Right.
So it stands out for me. The yellow on blue stands out better than black on white.
So what do you normally print these out on?
Well, I've used all sorts of different things, to be honest. So I've just printed them out on business card, and sometimes I printed them out and laminated them. Some people have a little bit of a problem with lamination, getting a total
Reflection.
station reading.
Hmm.
I've never really found that. I have actually put little dots with reflective tape in the middle, little circles, reflective tape. You get a punch and put that right in the center. But generally speaking, a matte surface is great, and then a lot of labeling stock is fine. All you really need to be able to do is measure where the center of that is. So it's only the center that you're really interested in and getting the crosshairs lined up. But I found this is the one I've used. I've used this design for 20 years, and although there are other targets, and you have to use these in some of the auto recognition ones. I can see some behind your head. I'm not a big fan of the checker targets because I'm an old school person. I like to manually pick my points because I trust it. Just call me old fashioned, but to me, this is just one. There are plenty of others out there, but I shared this because it's been a trusted tool that I've used for many years.
Right. Now, if you're doing photogrammetry and you're moving your camera around and you're getting some slightly different angles, how does this perform, for example, on a very oblique angle or a very shallow angle?
Well, because you're using the paired lines, it's a lot easier to separate them out. So you'd imagine those get elongated, but you're still trying to get the center. It's this human symmetry, it's this symmetry in the eye that helps. So if I'm shooting at an oblique angle, I've normally got some of the paired lines somewhere that I can use.
Right.
So I don't find it so much of an issue. Using the paired lines actually helps in those circumstances where you're shooting at an oblique angle to something. But to be fair, I try not to shoot at an oblique angle if I can avoid it anyway.
Yeah.
You wouldn't in photogrammetry. If you've got an oblique angle in photogrammetry, you're getting a bit, you've always got that sliding error, whether you're using a total station to measure it or you just using your mouse and your pixel. There's always that skid mark, if you like,
Right.
of eccentricity and lack of repeatability. So yeah, I haven't really found it a problem. There are, same with anything, if you go too acute. But I try to avoid those and set up so I'm shooting more perpendicular to the surface and wanted to pick up anyway.
Yeah. Well, that's great information. If somebody wants to get a hold of this target, have you made it available online someplace?
Yeah, so there's two versions. There's a PSD version, so you can put it into Photoshop and print it and change color and do whatever you want. And then there's a CAD version. The CAD version is interesting for me because there are certain dimensions on here. So like from the two larger rectangles, the outside edges, they're scaled to a certain distance. So you can use that to check calibration measurements. On my target, I think they're 100 millimeters apart, which doesn't sound like much, but sometimes just getting a sanity check on that, using it for scale, and the big circles are known diameter as well. So
Excellent.
there's a CAD model and a PSD. If they want to drop me a line, you've send the details, I'm sure.
Yeah, if I can
find me on LinkedIn.
Yeah, maybe that's what I'll do, or maybe I'll put a link in the video here for people to get hold of you, and they can just get the target right from you.
Okay, no problem.
Excellent. Hey, thanks a lot, Barry. Always insightful and always great information. I really appreciate it.
All right, good luck with the rest of the I'll be looking forward to seeing what other people say about targeting. I'm always fascinated. All right, thanks Eugene. Thanks for your time.
All right, cheers. Bye-bye.
Bye-bye now.
Okay, so there you have it. What I'll do is in the description down below, I'll make sure that I put a link to Barry's profile, or maybe one of the links that he has on his website or something like that, so you can get a hold of this particular target if you like it. Now, I want to talk about spheres. So spheres are really, really useful. And here you can see I've got this massive sphere. And spheres have been very popular with laser scanning, probably used a bit more with laser scanning. However, programs like PhotoModeler and programs like 3ds Zephyr can also detect spheres. They have a sphere detection algorithm, and they're quite robust too. So you can use them both for laser scanning and photogrammetry. Now, this particular one is a very oversized sphere. It's massive. It was just one that I was doing a test with. But often you'll see these spheres just like this. So something on the order of about 150 millimeters to 200 millimeters, 250 millimeters. It just depends on the kind of range that you need. So, the larger the sphere, the larger the farther that you can put it away. So the one benefit of the sphere, though, when I was talking about the checkered target before, you know, the checkered target, you kind of got to move to always face the laser scanner. And in the case of a sphere, you don't need to do that. And that's because no matter which direction I'm looking at the sphere, it's always spherical, okay? So I always get one side. And when I'm looking at this one side, if I can figure out with enough points on the surface where the center is, I should be able to find the center point in the same spot no matter which way I am looking at it. So that's the basic principle around the spheres. And because they come in different sizes, you can use them on smaller things. So these are bullet trajectory spheres, and these ones are used because the rod is actually quite small. And we're talking about a very small rod. You don't pick up a lot of points on the rod, but you pick up a lot of points on the spheres. And so this can be really, really helpful. So spherical targets are detected by a lot of different types of like equipment. They're used in metrology. They're used in scanning and photogrammetry. So a really useful tool here. So what about circular targets like this? Well, this is typically something that is used in photogrammetry more than laser scanning, although it has been used for laser scanning before. You probably won't find too many of these circular targets anymore for laser scans, though. But the ability to get down to the center point of the circle is something that software can do pretty well. And unfortunately, humans don't do very well with this. We can get down to about 1 or 2 pixels. But if you have an algorithm that looks at this and then tries to figure out the center, you can get down to like 1/20th of a pixel, something on that particular order. So a lot of people have kind of left the circular target. You don't see them as often anymore, although they are still quite useful for photogrammetry. But when we look at programs or software programs like PhotoModeler, we have now what are called rad targets. So I'm going to bring up my notes here because I've got some interesting things that I don't want to miss here. And so this rad target is something which is more robust than just a simple coded target, okay, with these little bits there. And so they're basically coded, meaning that they're unique. So each one of these targets has a little bit or a little part of the ring that is showing on or off, okay? And it's basically a binary system that's being used here. And if we look at a program like PhotoModeler, they were using dot marking, just simple dots in about the 1990s. And then they came out with coded ring detection. So just the little bits there in about April 2003. And then later on in January 2009, they came out with these rad targets. Okay, so and I've got some examples here. So that's one there. So this is one that you could put onto, this is a sticky one. You can peel it and stick it on something and, then take photographs of it or whatever. But also what's interesting is you can use them with structured light or hand scanners. And so this is another one here. You can see it's got a number on it. Okay, it's got a 120 here. So that's its number. And these rings will define what the coded target is. But also the freestyle here, this is the freestyle 2 from Faro. This will detect the same target. So those rad targets that were made by PhotoModeler are also detectable in the software when using the hand scanner. And this will help you with registration. So as you move around an object and then get back to the other side, it recognizes that, hey, that's target 120 when I first scanned it, and then I came around the other side, hey, that's target 120, and assuming that it hasn't moved, it should be in the same spot. And so it helps to kind of bring things together. Now there's different types of targets and things like that you can use. Like for example here, this is one where you have a series of dots here. So they make up sort of a unique pattern, and that could be used for photogrammetry too. But not as common anymore. People are going into these type of coded targets. And PhotoModeler uses these also for calibrating your camera. So you can print out sheets of these things. They even have a target where there's 2 beside each other, and it provides an offset. So if you made like a sharp point and you wanted to find the corner of something, well, you can't stick target in the corner, so you have 2. It has an offset, and it can figure out what is sort of off to the side a bit at a certain distance, like 50% of the distance or something like that. So that's pretty cool. Let's talk about April tags. So much like the rad targets that I just showed you, these are April targets, and April targets are being used both in photogrammetry, they're used for computer vision, they're even used for example, this is the dot product scanner, and the dot product scanner will recognize April tags. So a lot of this is used in robotics and computer vision and different places, but it's a really interesting design, and they're supposed to be quite robust. Now I was able to interview Max Krogius, who is a programmer or developer, and he's working with April tags, and he recently came out with a paper on a new form of April tag. And so I want to run that interview and just let you learn a bit about April tags. So here we go. Hey everybody, I'm here today with Max Krogius, and he is the first author of the most recent April tag paper, as well as the current maintainer of the April tag GitHub repo. He previously was a PhD student in robotics at the University of Michigan and did his undergrad in physics at McGill University. How you doing, Max?
I'm doing well. How are you?
I'm fine, thank you very much. So I've got a few questions regarding April tags, and that's because I would say they're probably a more recent tag or type of target that that people are seeing now. So I know, for example, there's a dot product scanner. It's a little 3D scanner that uses the Intel RealSense, and they use these types of targets. And also, there's a photogrammetry software that I use called 3DF Zephyr from a company called 3D Flow that uses these as well as their options as part of their targets. So the first question I have is, what is the advantage of an April tag over something like a checkered target or like a circle or something, a very simple shape?
The main difference is that you're going to have a whole bunch of different April tags that are each uniquely identifiable. And that, in addition to being uniquely identifiable, also brings in another advantage, which is that you don't have sort of like a false positive. If there happens to be a checkerboard already in your scene, maybe an April tag is a good choice as a marker.
Okay. Is there something about the shape itself, or does it have more to do with the algorithm that's looking for the April tag?
It has to do with the pattern of black and white bits that are in the center of the tag. So those contain basically some data that describes the tag. And
Okay.
There's only a limited number of patterns that are valid ones.
I see. Okay. So I know, like from my experience, I've used there's a company called Photomodel that uses the round targets. So they're round, but they're coded as well.
Mm-hmm.
And so one of the difficulties with these types of targets is that if the little, I guess I'll call them the bits, the little the little squares or whatever, if they're on and off, if they're smaller, then it's harder to detect from farther away, right?
That's correct. And I think, so I haven't actually compared against this particular fiducial target, but as far of the ones that I've compared against, April tags can be detected at the furthest distance when your tag is printed at the same size. And what that basically comes down to is just being careful with how you write the detector and processing every individual pixel.
I see. But with April tags, like for example, on a checkered target, or even on those other targets, like they call them, I guess I'm used to calling them rad targets because that's what the company Photomodeler calls them. They're basically just detecting the center.
Yeah.
So are you getting more information out of the April tags?
Yes. So we can compute the full 6 degree of freedom pose of the April tag with respect to the camera if you give information about the focal length of the camera and the size of the tag itself.
Oh, I see. So is that why were they developed for computer vision, like robotics and that sort of thing?
Right, exactly. So it's originally intended for robotics. So basically it lets your robot know exactly where the robot is when it sees one of them.
Oh, okay. Okay, I see. There were some papers that I was looking at, and I'm wondering if you could maybe help me out here. So,
for sure.
And maybe I should do this in order here. And I guess we should give a shout out to it's Edwin Olson, right? So he's the person who dreamed this up one day.
Exactly. Yeah, he's my PhD advisor.
Okay. Okay. And what do you know about do you know anything about how he got the idea for this or anything like that?
I'm not sure, actually. I don't know. I know there was some prior work in the same area of fiducial targets that also have kind of a square black and white border on the outside, but they didn't have the grid pattern of white and black cells in the middle that makes April tags as reliable as they are.
Okay, so this paper here is from the first introduction to this, I guess, was from 2011, and then there was another one also from Edwin Olson and John Wang, and this one here, efficient and robust fiducial detection. So what is this paper actually talking about?
The main change in version 2 is basically increased detection speed. I'm not sure how important that is for a photogrammetry algorithm or application, but for robotics, it's very important.
Sure. And what can you change? What can you change on a target to make it more or quickly detectable?
Actually, in this paper, the target stays the same. It's just the detector algorithm that's changed.
I see.
Yeah.
Okay. And you authored a paper in 2019. So flexible layouts for fiducial tags. Or now, was this part of your PhD?
Yeah, this was the first project that I worked on.
Okay.
And this one, we're experimenting with different layouts for fiducial tags, different ways you can basically arrange those data bits around the detection border. So like the example there on screen has one big tag and then in the middle a smaller tag. And then
I just noticed that now. I didn't notice that before.
Yeah. So the idea there is that you could detect the large tag when the drone is really high up. And then as you come in closer, you'd see the smaller and smaller ones.
That is a cool idea. I love that idea. That's a great idea. Yeah, sure. If you're really, really close, then why not just choose that?
Right.
So what revision are we at now on the April tags? Because there's been several iterations, right?
Yeah, this is number 3. So
this is number 3. So yours is the number 3. And you actually, let me bring up, there's a presentation that I might have here. Let me see if I can bring it up. No, it's not that one. Actually, it's this here. So the tag number, so it's this tag 36H11, for example, like over here. What can you tell us about the naming convention and what they mean and how they've developed?
For sure. So the first number there is how many data bits are in the tag. So how many of those black and white squares. And for each of these different tag layouts, we might have ones that are larger, that have more data bits, and one that have fewer data bits. So that's kind of a trade-off where the more data bits you have, the more different tags you have in that family, and the lower false positive rate you have for that tag. But the trade-off is that maybe now, since you have more of these bits, you can't, I mean, each individual one is smaller, and so you can't detect the tag from as far away.
I see.
So that's the first number there. The second number, so 36H11, the 11 says that any 2 tags in this family are going to be at least 11 bit flips apart. So you can take any of these little squares, change them from black to white 11 times, and you won't end up with another valid tag.
I see. Okay. So for example, obviously being unique is really important. I can see that. So there's probably some applications where you're like trying to, like for products or for like in commercial, applications or something, it's really useful, but I'm interested in what I'm doing. So for example, if I'm doing photogrammetry with a drone and I don't need 10,000 codes, which target would you recommend as being the most robust from far away? But let's say I only needed 20 targets or 30 targets.
Yeah. So I think, when you're doing photogrammetry, the photogrammetry software isn't really going to have the issue of figuring out where everything goes in the scene.
Right.
I mean, if that were the issue that you were having, then yeah, you'd want to use more distinguishable tags. But yeah, you can just use like the tag 16H5 or something like that.
Tag 16H5.
Which is basically a scaled down version of the 36H11. Because it seems to me that you basically don't really need any of the guarantees that you get with the additional data bits.
Okay, so this is I think this is one of them here. I printed out all the different ones. So this is a tag 16 class. So so you don't have as many bits. You don't have the squares are larger.
Exactly. I should point out that for a robotics application, this is a terrible tag because you will get real world false positives with this tag. And
I see.
If you're relying on that to decide where in the world you are, that could be very, very bad.
See. So yeah, okay. I think the photogrammetry software is probably, I don't think they're doing anything with orientation or anything like that. They're probably just detecting the center point, because usually it just shows up as a ground control point in the center. So I can see why they may want to do this. Although they do have some of the more recent ones. So maybe some you might recognize. This one is the 49. So it says Circle 49 H12.
Oh, yeah. So the idea with the circle one, and actually I think this printed out a little oddly, is that you don't actually need the bits on the corners, basically, so you can kind of form a circle out of the bits that you do need.
Okay. So do the
Sure.
okay. So as I flip through these, it looks like the corners are stationary. Is that what's happening?
Yeah. So you wouldn't actually need to cut them out and put them on your actual tag.
I got it. Okay.
So the idea here is really for something that is attached to a round object.
Oh, okay. I got you. I got you.
The area.
And so now, which one in your paper though? Which were the targets, the most recent targets that you worked on or created?
So all of the other ones, other than the tag 36H11 style ones. So all those other shapes are ones that.
Okay, so even the like I'm seeing here, tag standard 52H13, like this one here.
So the standard one, for instance, that's something that's new, which is useful for a robotics application because you essentially have that extra layer of data bits around the outside. The other thing that's useful for more of a pragmatic reason is that because the border is in the inside of the tag, a user is not going to accidentally cut out along the border. That's something that happens where people just cut off the detection border and then the tag is undetectable.
So what kind of things go wrong with the, like for example, with some of the lower, like let's say the tag 16, like what's a typical problem that you see in computer vision with something like this?
Yeah, so the way kind of the algorithm works is it looks at your image and it finds all the different quadrilaterals in the image. And it treats each one of those quadrilaterals like it's a real, possibly a real tag.
Mm-hmm.
And it tries to read out, well, what are the data bits on this tag? And if it, by chance happens to get a pattern of bits that matches this tag, you'll end up with it'll report it as a tag detected here, even if it's not actually detected.
Okay, I see. And so, are there people working? I mean, you finished this not very long ago because the paper you worked on was like 2019, I believe, or 2019 or 2020. Yeah. So, are there other things that you know of that are being planned for the April targets?
Nothing within our lab. Other groups are working on, for instance, one thing I've seen is incorporating color into the tag instead of just black and white images.
Oh, okay.
But yeah, other than that, I don't really know.
Actually, I think and the color was an interesting one. I think you talked about that because just recently somebody sent me a target that had different colors. So typically they've been like black and white or a very dark gray and a white, and then somebody had like a blue and a yellow or like something like that. It was like different colors, and I was wondering like why that might be helpful.
Well, so one, I guess there's kind of two reasons. One is to speed up detection. If you can look for sharp color gradients in addition to just intensity gradients, that can help you narrow down which quadrilaterals in the image are actually tags. The other reason that I've seen people do it is for making the tags look better if they're going to be installed permanently in a location, such as like some subway stations in New York City have April tags installed, and they're drawn in color, but the color has no actual functionality.
Oh, I see. Okay. And then in terms of how there's a slide here, it says, how do they work kind of thing. So what is it actually? So is it like, so for example, is it working something like the SIFT algorithm? Is it doing like, what's it doing when it's looking for the tag?
Right. So I can kind of walk you through this image here. So from left to right, in that first row, we have our input image first.
Mm-hmm.
And then the step one is just downsample it a little bit. So we don't actually need all the pixels.
Okay.
And then we're going to threshold it. So we're taking our grayscale image, turning it into black and white. And then we find connected components. So that's what the kind of weird colored one there, where we're finding all the areas of black that are contiguous, all the areas of white that are contiguous. Then we find the borders between those regions, which is the next one there. And then of those borders, we try to fit a quadrilateral to them. And so you'll typically have, dozens of potential quadrilaterals in a scene. So once you have them, you next have to read out what are the data bits inside of the tag.
Okay.
And there's a little bit of post-processing that goes on there, but that's basically the idea.
To figure out the degrees of freedom, or basically the orientation, are you looking at just the external profile, like sort of like how the perspective changes on the outer part of the target, or is there something else that it's looking like with the individual bits?
Oh, when you say rotation, do you mean like which side of the tag is up, or what is it? It's like 3D.
Well, what I mean is like
rotation in space.
it seemed like for example, when there's well, like these images that you're showing here are like perpendicular to the camera more or less.
Oh yeah.
But like
sure.
if you were on an angle, like can it figure out the sort of the orientation of the target?
Yeah, for sure. Yeah. So yeah, this is a very simple case, but it can detect the tag even if it's at an extreme angle.
Yeah. So
And it'll know
and what's it looking at when it does that? Like something like this, you know what I mean?
Right. Yeah. So I mean, it's still just looking for a quadrilateral in the image, and then what it does is it looks at the quadrilateral, the shape of the quadrilateral that it has detected, and just does offsets within that quadrilateral to figure out where each bit in the image should be, so that it can still read it out.
Oh, okay. Oh, that's super interesting. Well, it's a newer type of tag that a lot of people are seeing now, and it's coming up in different types of software and stuff. So it's yeah, pretty fascinating. And it seems to me what I'm learning here is that there's more in the April tag than actually what a lot of us are using it for.
Yeah.
Yeah.
I think that, I'm not sure I'm not that familiar with the field of photogrammetry, but I imagine some of this stuff might be more applicable as you move towards trying to make it happen in real time.
Right.
So if you need to basically assemble a model as you go, that's where stuff like knowing that this tag is unique, and yes, I know for sure that this is the only tag in the image that looks like this, that stuff becomes useful.
I think there's a message for the people who are developing photogrammetry software,
Yeah.
because if there's other information you can pull from these things, maybe there could be some things like setting up a rough estimate of the camera's position or something like that.
Absolutely. Yeah. I mean, it should be totally possible with these tags to estimate camera positions, and just, I imagine that would speed up at the very least the computation of the model.
Yeah, for sure. Well, listen, Max, thanks a lot. That was very insightful and some interesting information on April tags for people to learn from. So I appreciate your time.
For sure. Thanks for having me.
All right. Take care.
You too.
So as you can see, there's a lot of development that's being put into different types of targets and where they can be used for computer vision, for photogrammetry, for laser scanning, a lot of different areas. Now, I didn't talk a lot about where or when you decide when to use them or not. And that's really not the purpose of this particular video. And maybe one day I'll cover that as well. But anyway, I've got a couple of companies here that sell different types of targets. There's Laser Scanning Europe that has the tilt and turn targets. They have spherical targets, and there's also Koppa Targets that sells the bullet trajectory targets and things like that too. Both are great companies and good to deal with. And I put the links down here. I can even put them down below so that if you want to check them out, you can. Anyway, that's a quick summary about different types of targets, how they're applied and how they can be used. Hope you enjoyed this, and we'll see you next time on Click 3D. Take care. Bye-bye.